Evening, sir.
The party has
Good evening to you and to the other students. So, do.
Doing
We're doing
fine,
well,
sir.
sir.
We're
Sir?
okay, sir.
Evening, sir.
All right. So, again, for those of you who would not have heard or just joined, good evening. And I trust that you all are well, that you're doing fine, um, and ready to learn. What do I say to you? Did you all see the question that I posted?
Which question, sir? Where you post it?
No,
Was that the morning?
Oh, sir, I was asking which question and where you post it. Or you mean?
the share screen.
On my screen, yeah.
Oh, okay. Yes, sir. Seen it.
Have you done it, Ninja?
No, yes, sir. I've not done it yet at all, sir.
So we do it now, sir? That's why you're sharing it? Or
Yeah, I want it to be done now. I mean, it's a warm-up question.
okay, then just give us a fact and so we can do it and
All right, no problem.
Sorry, it's my response.
I am looking now. Thank you, Raj. That's correct. Good job.
Mm, oops. Supposed to send you the answer, sir.
You could, so that I can give everybody an opportunity to do it. TKL, very good. All right, so I've gotten 2 responses so far, and both of them are correct. Send them on, please. Quick and fast.
Sir, I send you a text. Just tell me if it right or wrong.
Are you guys okay with the solution now? I got some responses and they're correct so far.
Yes, sir. Okay, ready, sir.
Sir, question. I
Hmm?
wrote mine a little different way from that. So I wrote it as let y equal 4x squared plus 3x minus 1. And
Same
then,
difference.
okay, and then I had dy over dx equals to the answer. That's
Same
what.
difference.
Okay.
Here goes another one.
Sorry, it's showing. I'm not seeing example for sir. If that's the next one you're talking. Okay, see.
Or send you a response. And let me know if it's right.
I don't know why I feel this way, but the ones who have responded to me, there are 21 of you here, and it's less than half of the students have sent me something as a direct message and I've responded to them. I am concerned that a number of you not understanding what it is that we're doing. If you don't understand differentiation and integration, you can't move further in the course. Everything else from here is going to be dependent upon how well you differentiate and how well you integrate. Everything from here. I want to quickly undo this one. I need to also quickly introduce some other rules to you so that we can jump into the past papers to start working some questions. Come on, please. Please, please.
Tell you if I know, so I'm not quite catch it yet. But may I try something, sir? Based on the example we get last time.
No problem.
So with me now is the way they set it out can confuse me. Cause true, I used that certain pattern of differentiated. So when you switch it up now, it just unfamiliarized with me. I mean, I wonder how to do it.
Yes, sir. I kind of practice it for the polynomial, if that's the right term. So the fraction one, I kind of beat me sideways.
Same.
But I don't, but I don't understand. So why don't you just convert it to a polynomial? It is a polynomial, you know. It is a polynomial. It is still a polynomial. But why don't you, it's just that it's a polynomial in a different form. And I just put that there to see if you guys can recognize that it's still a polynomial. It's just in a different form. Question to you, how do you convert 1 over x to the 7?
So you mean to differentiate?
No, sir. How do you convert it? Can it be written in a different form?
X to the negative 7, sir.
X to the negative 7, thank you. And how do you convert 3 over x to the 5th power?
3x to the negative 5.
3x to the negative 5th power minus 4x squared minus 6. So what I'm saying to you is I can rewrite my function in another manner by writing x to the negative 7 plus 3x to the negative 5 minus 4x squared minus 6. So that is a polynomial. That is a polynomial. You with me, Mason? And Logan and
Yes, sir. Yes,
somebody
sir. Working on it,
somebody else,
sir.
right. Somebody else came on and said same. Who was that?
Same as me, sir. But I
Okay,
thought
look.
I was saying what you were saying is that even though I know it, when you change it up now, it's like it confused me. I'm
Okay,
not
all right, no problem.
accustomed to it like that. So are you sharing?
I but all right, you're supposed to be seeing the screen now. Let me know if you can see the screen. Can you?
Yes, sir, I can see it now.
All right, cool. All right, so you guys are okay with that one now?
Yeah,
Sir?
I think so.
Yes,
Yes,
sir.
please. Okay, good. All right, Matthew, please hurry up and send that for me. Or to me. Um, uh, um, all right, I've just projected the solutions to the solution to the question I just gave. I'm going to introduce another rule to you.
Sir, when you say another rule, what do you mean?
Oh, there are several rules to differentiation. The
Oh,
rule that I've introduced it
Chain
is a
rule.
chain rule. Yeah.
oh.
So I'm going to introduce it to a few more rules now. All right. All right. All right, I come in. All right, what I'm going to do is, yes, Matthew, I think so too. Mhm. Okay. All right. So I soon talk to you, Matthew. Let me caution you on something though, guys. When you are given the more, be careful. When you have a negative sign, please to make sure you write it. Please, you have to be very careful. Hold on a minute, please. All right, guys. So I am going to be introducing you now to what it is that we call the power rule. And I'm going to ask that you just look through this. Okay, so remember the meeting says not tonight, all right? The meeting says not tonight.
Sir,
Uh-huh.
what's going on?
Huh?
They must be
What?
well prepared for it.
Yeah. Maybe that if it's all by weekend.
Same here.
So
Who said same here a while ago?
Speaking. But sir, I'm not where I'm supposed to be where this
No, but hold on. Was it the
Hmm?
conversation? Was it the conversation last class that we're going to? Was it the conversation last class that we're people don't get home on time on a Tuesday, so therefore
Yes,
we'll put the wasn't that a conversation?
that was a concern. And T Kelly, tried to do some politics, which you advised him to go into politics. But
Right, but the thing about it is that there are students who would have had to be contacted, and we would not have had a meeting. I mean, or not a meeting, but any conversation, because I would not have spoken to those students to
very
know
true.
to
It
know.
wouldn't be
Okay,
fair
sir.
to
Understood,
have a
sir. No
1v1 where
issues.
Very true, sir.
more time to practice, sir.
No
No,
issues,
yeah,
sir.
no,
I got 100, so no issues. Understand?
oh no, it's just that I'm seeing some messages in private messages and to me, and kind of hearing or sensing that I kind of put out people out of their way, but
Oh
based on
no,
the
no, not
politician.
put out the
Go
way.
ahead.
Not that case, sir. Put
No,
out.
but no, let me know, because if you want it, you can get it now, because I have it.
Not at all. We'll wait
Okay.
until we'll wait.
Okay.
Sir,
I
sir,
was just checking. Yeah.
sir, spell it, make we use it, go and practice.
Your favorite child. Your favorite
Sir,
teacher.
I have a favor to ask.
Go ahead.
I'm sorry,
Go ahead, please. Somebody's asking a question. Who is that? Is that Logan?
It's Chris, sir. I think she's still on the road, so maybe she's having internet
that
issues.
is it towards the end of class to go over differentiation when it comes to fractions and how the specific part I'm having is the first part when it injects it into the differentiation principle.
I really don't understand the question, Christian, honestly.
Aye.
So I
All
think
right.
to be
When I set up myself at home, I'll ask again.
Yeah, please, because I really don't understand the question. All right. So am I allowed to continue?
Yes, sir, but
How
Yes,
long
sir,
you
continue.
for the first rule? So for the first rule, I'd love if you maybe just go over that just one more time before you move on to this other rule.
All right. Give me a minute, please. Give me a minute, please. A minute. Sorry.
Sure.
All right. So I'm somewhat a little bit more settled, and I want to get the understanding from what it is that you're asking. So somebody was asking before a few minutes ago, you want me to go through the question that we did on the fractional one I just did a while ago before I move into this. Am I to understand that was a question?
And also the first rule entirely, please.
Taj, were you in class?
So I was, to be told, I was more focused on, thinking that the exam or the test would have been today. And
No, but
all focused on that, truth be told. And I didn't think this would be a part of what we'd be getting. So I never looked at it, truth be told.
yeah, but Taj, what it causing me to do now is that instead of me going forward, I'm going to go backwards. All right. All right. I'll oblige you this one time, but I won't be doing it every time, right? Because
Definitely, sir.
okay.
Appreciate it.
All right, cool. Okay. So in a nutshell, what we do when we're differentiating, we are given a function y equals x cubed. The rule says y equals x to the n. The n is going to become the coefficient, and then I subtract 1 from the power.
Okay, got that, sir.
All right. So it's n. This n becomes a power, the coefficient. So this is what, so this power here is the same n here, and then I'm reducing this n by 1. So y cubed, y is equal to x cubed, sorry. dy by dx, I heard TKL says that he didn't use my f of x, but he used y to get dy by dx. Same difference. Same difference. So this is going to be 3 in front, which is here. And then I'm reducing the power by 1. So it's going to be 3 minus 1. 3 minus 1 is 2. So the differentiation of y equals x cubed is going to be dy by dx is equal to 3x squared. All right. In another example, what we did, I rewrote the question to them for the class, explaining that even though this -3 here, a constant, you're not seeing a power or a variable beside it. There is indeed, and in fact, there is a variable. It is x to the 0. It is x to the 0. But this x to the 0, if I were to use this power to multiply by the coefficient, I'm going to get 0. So that's why the differentiation of a constant is equal to 0.
0. Yes, I remember.
Right. Right. And then no, so whenever you see a constant, a term standing by itself, and you are differentiating, you're going to get 0. You're going to get 0. Why? Because the differentiation of a constant is going to be equal to 0. And then this 2 is going to be multiplied by this -3 to give you -6. And you're reducing 1 by the power. So it's going to be 2 minus 1. So I have it here. And 2 minus 1 is 1. So I'm going to have -6x to the first. See here? -6x to the first. So I'm not seeing to the first. We don't have to write it.
Right.
And then this now -2x to the first power. It's going to be 1 times -2 is -2. X to the 1 minus 1. See here? But 1 minus 1 is 0. And anything raised to the power 0 is 1. So therefore, I'm just going to have 9 minus 2. So that's how we got up to that point.
Okay.
And then the third example, was the one I gave for a warm-up. The one I gave for the warm-up.
Okay, I see why this is looking so. Makes perfect sense. Thank you, sir.
No problemo. Are you sure you see it right?
I'm positive.
All right, good job. Okay, no. So now, having done that, we went ahead and looked at this other example here. And that other example, we were looking at we're looking at 1 over x to the 7th power plus 3 over x to the 5th power minus 4x squared minus 6. Remembering that it is still a polynomial. All I had was something of a different format. And what it is that I'm doing here is just to put it in a nicer format. Sir, then if you went to the exam, you always have to convert like that. No, I don't teach you the quotient rule yet. So for the quotient rule, you can work the question as it is here, but because we don't do the quotient rule yet, I am giving you this method and show you that the question can be written in different forms. So I'm converting 1 over that. Okay, now let me just point out something here. When you see something like this, please do not go ahead and find the LCM. Don't. When you see this, please do not try to find the lowest common multiple.
Yes, sir. Can we now do the limit of
Yeah, man, please
of
don't.
infinity?
Yeah, you know do that. Just go ahead and just differentiate the terms individually. All right, and then now we get to the stage where we're now looking at the power rule. And let me present the power rule to you pretty quickly.
Sir, so like how you have it here, sir, we can do it in the exam, sir?
How? What?
Like how you have it here, so we're converted from the 1 over a to positive m.
Oh, absolutely.
Okay.
Oh, absolutely. Yeah, man. Remember, I'm not teaching you to do things one way, because there are several ways to skin a cat. Several ways to cook chicken. No, man. I'm showing you the methods, but I'm giving you in trunk size. So because I'm in the quotient, the chain rule, I'm showing you the question, how you can convert the question from one form to a different rule, which is a chain rule. I can come back to this question when I teach you the quotient rule, and you attempt the question using the quotient rule to see if you get the same answer. And you can figure out which of the rules is easier for you to use, so forth and so on. Okay, so given y equals 2x plus 5, all raised to the 2nd power, we need to find dy by dx. We need to find dy by, you know why this is called a power rule? Anybody can figure out why it's called a power rule?
Sir, we're not seeing this, sir. We're seeing we call it the fractions.
That's not true. You're
No,
seeing
we're
it now.
seeing it. Really, sir?
Sir, because it deals with indices.
Because it has an index up top. Yeah, it has an index up top. All right. So you so you have y equals 2x plus 5 to the 2nd power, and you're supposed to be finding dy by dx. You're supposed to be finding dy by dx. Now, it is called the power rule because of that index. It is called the power rule because of that index. It is called the power rule because of that index. All right? Now, guess what? The question is going to be done in a similar manner, like what I taught earlier. However, we have one additional step to take. You're going to have one additional step to take. Watch me. This 2 is going to multiply in front of here. It becomes a coefficient. See it right here, so. Then I'm going to write back my 2x plus 5, and I'm subtracting 1 from the power. 2 minus 1.
Hold on a second, go again.
So you see, it's subtract 1 from the 4.
Yes, sir. Go
Yeah.
again.
I don't understand, no? What want to know?
No, sir. How many think it was, sir?
Sir,
Is it
based on the
because
formula we
to the power 2 outside of the bracket, sir? It would have got in front of the brackets to become the coefficient, and then a minus 1 from the power.
And you get?
And get 1, but we not understand I get the 2.
But we not reach this yet.
Okay, sir.
We not reach this yet, you know?
You say go inside the bracket, sir, so I'm free.
No, I never went in the bracket.
I never went inside the bracket. All right.
No.
Go again.
Hear what I'm saying. Just listen to what I'm saying, guys. So the question is going to be done in a similar manner like what we've been working with just one additional step. Y is equals to 2x plus 5 to the second power, and you're asking us to find dy by dx. Dy by dx is going to be equal to the same thing like what we did before. You're taking the power and you're multiplying so that it becomes a coefficient. Can you see that?
Yes, sir. See that? No.
Okay. And then we are going to write back our 2x plus 5, and we are subtracting 1 from the power. 2 minus 1 equals?
1.
1. Can you all see that?
Yes, sir.
Is it any different from what it is that we've done so far?
No, sir.
No, sir.
No. No. Here goes the difference now. One additional step. We have to now differentiate what is on the inside of the parentheses. When you differentiate 2x plus 5, when you differentiate 2x, what do you get?
2 plus 0.
2 plus 0, which is?
2.
See it right here, so no?
Okay.
That's the 2. So recall, the times 2 is obtained from the differential of what is inside the parentheses. You'll always multiply by the differential of the inside of the parentheses. So whenever you get the power rule and you perform your differentiation, just like how Sir taught you how to perform differentiation, y equals x to the n, dy by dx is going to be equal to n x to the n minus 1. You're going to do all of them fandangles there. You must always know, go and differentiate what is inside of the parentheses. You must. So we're required to differentiate inside the parentheses. To apply the power rule, the index must not be equals to 1. If the index is equals to 1, it's not the power rule. If the index is 1, it's not the power rule. Look at that one. Do you think this is a power rule?
No, sir.
No, because the index is 1. Power is 1. All right? So I am going to project those two things for you. So what it is that we're going to look at now is going to be this 2 times this 2 will give me this 4 times the 2x plus 5. 2x plus 5 raised to the first power is simply 2x plus 5. Anything raised to the first power is just that same thing alone. Do you agree with that?
Yes, sir.
Good. And now because the power is 1, I can distribute this 4 over my parentheses. If the power was greater than 1, I could not do that because BOMDA says I have to work the brackets first. But because the power is 1, I am allowed to just go ahead and just distribute. So 4 times 2x is going to be 8x, and 4 times 5 is going to be equal to 20. All right. I am going to give you a couple of minutes. And I'm trying to keep everything on one page. All right, I'm going to give you a couple of minutes. And I'm going to ask you to look at that. And then we're going to find a question in the past paper. And I want you to do that for me, because I want you to be able to, this exercise now, when I'm sending you to find the questions in the past paper, it's because I am teaching you now how to identify your questions so that you can find your questions on your own. I am not babying you guys. You guys are bright students, you're computing students, and I want you to come to your class always prepared. I don't know about the other teachers, but when you come to sir class, you can come to class to do work. Don't think that sirs when you come and do all the work. No. You need to come with something in your hand. You need to come and give me something. Every night you have to come and give me something. So going forward now, try make sure, well, not even going forward, because we have been doing this. We have been utilizing our past papers, but even more so, every night you must have your past paper so we can go through the stuff. All right, so I'm gonna give you a couple of minutes. I'm gonna give you a couple of minutes so that you can go ahead and a couple of minutes so you can go ahead and look back at what it is that we've done. Following this, I'm gonna ask that you can just click the question and just put it in the box. I will do the question along with you, and then we can have conversations about it. But just allow me to just say one or two things more before I give you an opportunity to look back at it. Because what my aim for tonight's class is to go through the rest of the rules. So I'll give you the rules and maybe give you one example of the rule. And then now that I know you have all the rules, then we can go into the past paper fully to just work differentiation questions. So what I'm saying to you is, looking at the power rule. So how do I identify the power rule? The power rule is going to be identified. One, pair of parentheses with a power that is going to be greater than 1. With a power that is going to be, say it again?
Oh, sir, I just said 1.
Right. It has to be a power greater than 1, because if the power is 1, it is not considered the power rule. So once you have something with parentheses, a plus ax plus b raised to the second, third, fourth, negative fifth, once it is greater than 1 or even less than 1, once it is not equal 1, then it's going to be the power rule. What you'll do, you'll differentiate normally. Y is equal to x to the n, and I'm speaking the language now. You notice I'm not showing it on the screen. I'm speaking the language because I expect you to be able to know the language. We've gone through this last class. I did a quick revision just now. You have the information. Y is equal to x to the n. So therefore, dy by dx is going to be equal to n, x to the n minus 1. Dy by dx is going to be equal to n, x to the n minus 1. All right? So you're going to be differentiating the power rule in the similar fashion. The same way we differentiate the polynomial is the same way we're going to differentiate the power rule. But you're going to have one additional step more. One more step. And this is one of the things, and that's why I went through for Taj a while ago, because if I didn't, he would have been lost. And somebody sent me a message and said, boy, sir, thanks for this, because I also missed the class. Students, important. You're going to differentiate the power rule in a similar manner. So for example, you have y equals 2x plus 5 to the 5th power. Dy by dx is going to be equal to that 2, the power, is going to be differentiated, rubbishness. It's going to be multiplied and become the power, the coefficient rather. Good night, my dear. Thank you. Yeah, man. Cute. So you're going to use that power to multiply as a coefficient. You're going to write back the term, and you're going to subtract 1 from the power, just like we've normally done. Nothing different. Here goes the difference. you must, every single time you get a power rule, you must now differentiate what is inside the parentheses. You must now differentiate what is inside the parentheses. And when you do that, you will see that you're right. You know what? I want to give you an exercise. And this exercise is one that is good for the brain. All right, so you have 2x plus 5 to the 5th. Do you know how to expand that function? 2x plus 5 all squares? Can you write that in another form for me, please? 2x plus 5 all squares is what? Written out in expanded form is what?
2x plus 5 times 2x plus 5.
Oh, excellent. 2x plus 5 times 2x plus 5. And now what I want you to do is to distribute that for me, please. I want you to go ahead and distribute it for me and tell me what to get. 2x plus 5 times 2x plus 5 equals? I want all of you to work it out, please.
So,
4x squared plus 20x plus 25.
I got 14x plus 35.
I got 4x squared plus 20x plus 25.
Yeah, same here, sir.
Yeah, same here, sir.
TK, was that you? I heard you saying something about 35.
No, 25. So 4x squared plus 20x plus 25. That's what I got.
What say the rest of you? That don't sound right. That Mr. Richards did, you know. Anybody else get anything different?
So I got 14x plus 35.
Plus 35?
Yes, sir.
No, sir. I mean, I trust that neither.
Sir,
I more
I
trust Richard something. Go ahead, Logan.
my question, when you have 10x plus 10x, how do you present it?
When you have one apple plus another apple, we get
2.
okay.
So
No, 2.
2 apples.
Good. So when you have 10x plus 10x, what you get?
So it's like 2 10x or 10x squared.
Logan.
Yeah.
When you have one apple plus another apple, what you have?
2 apples.
Good job. When you have 10x plus 10x, what you have?
2 10x.
If me give you 10 sweetie, and me give you another 10 sweetie, how much sweetie you have? 2 10 sweetie?
No, 20.
Okay. So what is 10x plus 10x?
20x.
Good job. Yes, 20x.
Oh.
Nice job. Come the
So
rest of you.
so is it 4x plus 10?
No, I am worried. I'm very worried. I'm very worried. Let me tell you what I'm worried about. I'm worried about you guys don't know how to factorize. And these are my year 3 students. How on the way to do stationary point? Jesus.
So true,
Never
I
be.
don't remember. Because a long time I haven't done it.
Don't tell me say you don't remember nothing. Don't you remember how to eat? If you not eat for 12 hours, don't you remember how to eat after that?
Sir,
So I just
Yeah.
swallow instead of chew.
Ah,
I'm too hungry. So I
Craven,
forgot for
Craven,
chew. Just swallow
Craven,
everything.
Craven. Sorry, who was saying, sir?
Sir, it's me. I told you foolishness, sir. It's actually 4x squared plus 20x plus 25.
Because me, I wonder how you get 35.
Sir,
Sir,
that
was
what it say
just
first,
a
sir?
mistake,
Oh,
sir.
sorry, when you say this, sir, why you sit down there
Isn't
and
that
discuss
What
what
up, me I say?
my
Then that what it say
feels like
first, sir?
No, Nigel, Nigel.
Hmm.
Don't say we. That pronoun is wrong because it's only TKL alone that answer me. And
I
because
must say
when it says
CM.
TKL, say,
No,
you
sir, I
never
must
hear
say
CM was
nobody.
CM,
answered,
sir.
sir.
No, sir.
You
Other
never hear nobody
persons
say,
answered.
Yeah,
Sir,
man,
Yes,
I
sir,
answer you,
yes.
sir.
Ryan,
Don't make you look so
Ray
bad,
Well
sir.
said
then.
same. Nigel said
we
same.
never hear nobody say the same. TKL come out and say, sir, I got 4x squared plus 20x plus 25. And I say, if I say yes, everybody will go stop work. So I say, I don't trust that. Me no, and when me say I don't trust that, me not hear nobody come out and say, same, sir.
Sir, that's why I was saying if 10x plus 10x are the same thing.
We said
I
it,
got the
sir. Probably just
4x and I
didn't
got
hear.
the 25. So
You know,
sir,
need for
you
do.
said the therapy bill, because me can't take them
Only need,
gaslight in there. You
only
have
need for go, only need
PTSD.
for go repent and go study the factorization. So
No,
yes,
sir, what it say, man. Real talk, sir.
me never hear it.
We said it, sir.
Never listen to the recording and never hear if anybody did say same. And then now I remember Hamilton came in and said something else. I was like, say what? Where you get 35 from? But anyhow, so yes, 4x squared plus 10x plus 25. Now, what I want you all to do now is to differentiate that from me and tell me what you get.
But what you say a while ago, that not so
Sir,
right,
let's say,
sir.
bring in, sir.
What you say a
4x
while
squared
ago,
plus
that not right,
20x
sir.
plus 25?
no,
I
right,
10x I say
sir.
that,
Remember
sir.
the 2x. 2x
I,
Yes, sir.
I
times
said it to see
2x.
I said it to see if you're paying attention.
No,
Read,
sir. Can't repeat.
Sir, you need to repent.
sir, I can't.
I
Yeah, do that.
said it. Gonna leave you alone, man. Sure.
Yeah.
All right. So it's 4x squared plus 20x plus 25. So go ahead with that differentiation for me, please. Remember, you can't just go ahead and just get something like that and say when differentiate it. You have to first name the function so you can differentiate it. So you can't just say 4x squared plus 20x plus 25. Therefore, dy by dx equal. That no make no sense. You have to let y be equals to 4x squared plus 20x plus 25. And then you can talk about dy by dx. And you don't have to use y. Remember, somebody asked a question, I could have used f of x or g of x or whatever. Give the function a name, and then you're going to use the nomenclature of it. If you're giving it any other function other than y, your first differential will be that superscript dash. The single dash
I'll get the same answer.
signifies your
Like I said, get the same 8x plus 20, though, sir. Sir?
Sir, we're not hearing you here.
Look like him in the job.
You know, mute, but I don't know if he's, you have to step away suddenly or the mic just decides it's
No, man, jump off, man.
battery dead.
I say 8x plus 20 to make it.
all right.
I said,
I'm
sir?
I talk a while ago. The same 8x plus 20 me get. By the way, are you guys hearing me?
Yes, sir. I hear you.
No, we're hearing you, but it did go quiet
All
for a while.
Yeah, man. My internet apparently is unstable because I got reconnected. But when I came back on, I heard somebody say, make it by the same answer, 8x plus 20.
Yes, sir.
Did everybody get that 8x plus 20?
Yes, sir.
Yes, sir.
All right. No, so let us have a conversation on this. Now, you recognize that if you get a question like this in the exam. Somebody was saying, if you're going to the x plus 5, it's by the x. No
Sir.
function. Yeah.
Sir. Sir, internet are cheap.
Yeah.
Share screen, sir.
Are you hearing me?
Yes, sir.
Okay, all right. I'm afraid to share the screen because I don't want it. All right, I soon share the screen, but just listen to this story. I soon share the screen. Listen to this story. If you're to go into the exam and they said to you, y equals 2x plus 5 to the second power, and ask you to find dy by dx, you have two options. You can go ahead and expand the function by multiplying 2x plus 5 times 2x plus 5 to get your 4x squared plus 20x plus 25. Yeah, man, I'm not sharing a screen. I'm not sharing a screen. I just want you to listen. All right. So if sharing my screen makes you hear better, let me go ahead and share it. So what I'm saying to you is when I distribute my 2x plus 5 over the 2x plus 5, I'm going to get 4x squared plus 20x plus 25. Are you agreeing with me?
Yes, sir.
All right, great. When I differentiate that function, y equals 4x squared plus 25x plus 20x plus 25, I'm going to end up with my 8x plus 20. And you will recognize that if I were to use the power rule, I will still end up with my 8x plus 20. Do you agree?
Yes, sir.
Yes, sir.
Good. So I'm saying to you, the option and the choice is yours. If you're going to the exam and them give you a question like that, do it. But can I tell a secret? It's because the man them don't want you to multiply 2x plus 5 times 2x plus 5. You know the man them going to do? Give you something like 2x plus 5 raised to the 5th power. So technically what the man them doing is forcing you to use the power rule. Because nobody's going to sit down to multiply out 2x plus 5 times 2x plus 5 times 2x plus 5 times 2x plus 5 times another 2x plus 5. Nobody has time for that. We have 2 hours to complete the exam paper. So you have to learn the power rule. So I'm just showing you the different rules that we can use to stuff. All right. Having gone through the proof of that question, and I've shown you the proof just now, I want you to, are there any questions? Are there any questions? Are you hearing me?
Yes, sir.
Yes, sir. No question. Yes.
All right. Do me a favor. I'm going to give you 2 minutes or 3 minutes. No, let me not do that. I was going to give you some time to find a question on the past paper, but I think it is best for me to just go through something else. So we look at the chain rule, we looked at the power rule. I'm going to move it into my product rule. Now, they say that the best singers are those who do math, because we can DJ very well. Other teachers teach differentiation very different from how Mr. Shan teach it. So if you learn differentiation previously, you have a choice to use that previous method versus a method that I'm going to be teaching you. All right? Hear me out. Product rule. It's the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. And at this point in time, you should be writing the first. No, you can say product rule. You can say the first times the differentiation of the second plus the second times the differentiation of the first. When you hear product rule, what comes to mind? What are you looking to see? Go ahead.
Multiplication.
Multiplication, very good. And what do you think you're multiplying?
What outside the bracket by what in the bracket?
Okay. You're multiplying how many terms based on what it is that I just gave you?
One term by two.
How many terms do you think we're going to be having in total?
Two
terms, sir.
Sir,
How
two.
you know it's two terms? How you know it's two terms?
Sir, because it says the first times the
Very good. And you see, this is what it is, you know. You have to read with understanding and extract the information that is given. So it says the first times the differentiation of the second plus the second times the differentiation of the first. It never give you a third or a fourth. It spoke about first and second. So you're going to be expecting a multiplication. How you know that? It says times. And then it talks about a first term and a second term. So you're going to be having two terms. One of the terms you're going to call the first, and the other term you will call the second. One term you're going to call the first, the other term you're going to call the second. Now I'm going to be presenting the question.
Can I zoom in?
I could. How much you paying?
2 beers.
By the way, where's Alvin? Why does he talk about beer?
He's still having some connection and stuff issues, so he's not able to access class at this particular time. But we are sharing the notes with him, and he's actually right alongside us working questions.
Good.
So he's still there.
Tell him say him owe ya beer or una beer for that.
Sir, I
All right.
help understand some of my question them. So
I love it. I love it. I love it. I love it. All right, so let's go. So I want you to affix your eyes on the screen. And while you are fixing your eyes on the screen, you notice my little story is not up top, but I'm going to remind you of the story. The first times the differentiation of the second plus the second times the differentiation of the first. Sir, you never did use the word differentiation. He said differential. Same difference. I can speak about the differential, or I can speak about differentiation. Same difference. The first times the differentiation of the second plus the second times the differentiation of the first. Or the first times the differential of the second plus the second times the differential of the first. So I'm going to use one and multiply by the differential. Then I'm going to add it to the second one and multiply by the differential of the other one. So it's a crisscross something that we're doing. Look at my first. What did I call my first?
2x squared.
2x squared.
And what did I call my second?
5x minus 3.
5x minus 3.
All right. So watch me now. The first. Anybody see me right by the 2x squared?
Yes, sir.
All right. So you say anytime I call the first, now write it back. Times. When you see parentheses, what comes to mind? The multiplication.
Multiply.
Right. Multiplying and multiplication. Good. So it's the first. So I'm going to write back my 2x squared. So when I call it, TKL, present, sir. Nigel, present. You're showing up. So the first, I write it back, 2x squared, times the differential of the second. What is the second?
5x minus 3.
5x minus 3.
When I differentiate 5x minus 3, what do I get?
5.
I get 5. So you see what I have there? The first, 2x squared, times the differential of the second. The differential of the second is 5. So I'm multiplying by 5. Then what do I do next?
Plus
The
So you add
second.
that to the
Plus the
second.
second. Very
plus
good.
second times the differential of
Very, very good. Plus the second. The second is 5x minus 3, says anyway, plus 5x minus 3. And of course, I'm going to put it in the same format, keeping it in the parentheses. I'm keeping it in the parentheses. And then now it says plus the second times the differential of the first. Uh-oh. What is the first again?
2x squared,
When I differentiate 2x squared, what do I get?
4x.
Good. Look at it and tell me if you see 5x minus 3 times 4x.
Yes, sir. Yes, sir.
Now watch me now. You see what I have in blue right there, so? That is the end of differentiation. You see everything else in black and red is algebra. Differentiation ended right there. And hear the story. Look at it. The first, 2x squared, times the differential of the second. The second is coming to you, Damoy. The second is x minus 3. When I differentiate 5x minus 3, I get 5. So that is it. Plus the second, 5x minus 3, times the differential of the first. When I differentiate 2x squared, I'm going to get 4x. Differentiation done right there. So now, hear what? Don't expect to go into the exam for them to give you my story. My story is my story. Nobody else teach it like this. You will always hear me say the product rule, the first, times the differentiation of the second, plus the second, times the differentiation of the first. Go ahead, Damoy.
Sir, you can read the first and the second, so you can get the blue part again, please.
No
Can I
problem.
go through it fast?
I went through it fast. Let me ask a question. Anybody else, anybody in the class understand what I'm doing?
Yes, sir.
All right.
Do it
Is there?
over.
I will do it over. But the only, you have to promise me something, you know, guys. At this pace that we're moving, I am behind. So I'm going to ask that you turn on the listening ear and you clean out the fog of the glasses and rub out the matter them out of your eye. Come, let's go. Let's go. The product rule. So you're given a function to differentiate. But the function says 2x squared times 5x minus 3. And you're going to say to yourself, but hold on. This is a product. This is a product. How on earth am I going to differentiate this product? Oh, but there is a product rule. There is a product rule. What is the product rule? The product rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Once you know that, you are good to go. Differentiation is going to be seamless for you. The first times the differentiation of the second plus the second times the differentiation of the first. Work with me. For example, you're given 2x squared times 5x minus 3. You know, I have been teaching for some time, and some students will say to me, sir, I don't have to write down what the first is and write down what the second is. I will remember. And I'm saying you're even better than I am, because having been teaching and doing this from a idea my knee in high school, I still have to write down what my first is and what my second is, because you have a tendency to make mistakes. And some people don't write the first and don't write the second, and then when I'm marking the papers, big mistake. So take my foolish advice so that you don't lose points unnecessarily. Write atop the term which one is the first and which one is the second. Sir, does it make a difference which one you call the first and which one you call the second? It really doesn't. But what I normally do so that I don't get confused is to call the first one first and call the second one second. But I still going to write it. So you notice on my paper, I put first and I put second. Please follow my instruction. A word to the wise. So having labeled my first term and my second term, and I know that the function is equals to y, I'm therefore going to be finding dy by dx. I'm therefore going to be finding dy by dx. dy by dx is really the rate of change of y with respect to x. So what I'm going to do now is, I'm going to be saying which of the things that rules I'm supposed to be using for this. And then I say, but hold on. The 2x squared is being multiplied by the 5x minus 3. Once you're doing multiplication, there is a rule that speaks about multiplication. What is that rule? It's called the product rule. What is the product rule? The product rule is the first times the differentiation of the second plus the second times the differentiation of the first. Here goes. The first, I call the name, show up. I'm going to write down my 2x squared times the differentiation of the second. So it means right there and then, I must now go ahead and differentiate the second term. What is the differential of the second term? 5x minus 3. When I differentiate 5x minus 3, I'm going to get 5. Sir, how do you know that? Because when I differentiate 5x, I get 5. But the differential of 3, either positive 3 or negative 3, is a whole number, is a constant. It's going to be 0. The differential of a constant is equal to 0. So the differential of 5x minus 3 is simply 5. So it's going to be 2x squared times 5. That's the first half of it. Then the rule says plus the second. So I must now identify from what I would have written up top, which is my second, and I just write the second. What is the second? I call the name, show up 5x minus 3. And then now it says times the differential of the first. I'm going to be looking back at my first, and I'm going to be differentiating it. When I do that, identify my first is simply 2x squared. When I differentiate 2x squared, I'm going to get 4x. So how you know? Remember, y is equal to x to the n. Therefore, dy by dx is going to be equal to nx to the n minus 1. So I'm going to say 2 times 2 is 4. And a minus 1 from the power is no longer 2, so it's going to be 4x. 4x to the first, really. But we don't have to write 4x to the first. We can just write 4x. Then, sir, what if I write to the first power? Will I get it wrong? No, you won't. Well, you just lose half a second right there, so we're going to move on to something else. All right? The question finished right there, so. Well, the differentiation, I'm sorry, ends right there. What is left now is just algebra. The differentiation ends right there. What is left is just algebra. So I'm going to multiply the 2x squared by 5, and I'm going to get 10x squared. 2x squared by 5 to give me 10x squared. Can you see that?
Yes, sir. Yes, sir.
Good.
I understand it now.
Good job. And then watch this one, because this one is tricky, you know. 5x minus 3 times 4x. 5x minus 3 times 4x. It's going to be 4x times 5x. It's going to give me 20x squared. And that 4x again, multiplying by minus 3 this time, to give me
minus 12x.
Minus 12x. Oh, Lord. I'm losing power. Hold on. Let me just see if I can get some power here. Yes, but you're correct. They call it minus 12x. And then now I am going to be combining like terms. So 10x squared plus 20x squared is 30x squared minus 12. And, you know, to just put things in a nice little format, I can say, boy, 6x is common to both. So I'm just going to go ahead and factorize. You know what I want you to do for me? I want to prove this. Because this when you prove it one time, you don't need to prove it again. I want you to make sure, I want to show you, convince you that this method works. So do me a favor. I want you to go ahead and distribute 2x squared over 5x minus 3 and get a polynomial and then differentiate the polynomial and tell me if you get the same answer. Similar to what we did for the power rule. I give you 5 minutes. I'm muting.
Sir, so that's 2x squared over 5.
No, man. The same question, but you're just going to distribute. You're going to remove it from the parentheses. So you're going to multiply 2x squared by 5x and 2x squared by negative 3.
Oh, so you mean just do it like a normal, like how normal do it?
Right, but you have to do the multiplication part first. You follow me?
Yes, sir. Yes.
All right, good. Okay, this is, I need to be charging this.
Yes, sir, I got it.
All right. So tell me now. I heard one person said, yes, sir, I got it. How about the rest of you?
Yes, sir.
Yes, sir, clear.
All right, good job. I'm happy. Now, you know what I'm a little saddened about? There is at least one student in the class who still don't have a clue what is happening. And let me tell you what I'm saddened about is that the student or students
Sir.
refuse to say something. And then the student is going to formulate a notion that either the teacher can't teach or you can learn online and online don't make no sense. And that's not true. I've given you many opportunities to say to me, sir, can you repeat yourself for me? Or sir, I'm not understanding. So hear me, let me create another opportunity for you. Is there anyone in the class who is not seeing what is happening here or would love an opportunity to look back at this question? Or is it that I can move into another rule?
Sure, can you go through the proofing part of it? Because I tried to do the proofing part where you, sorry, 1 second. Can you go through the proofing part? I tried to do it, but it just confused me.
All right. What is 2x
I
squared?
understand the rule, but the
Yes.
the proofing thing, that confused me completely.
No problem, Papa. Tell me though, TKL, what is 2x squared times 5x?
That's 10x cubed minus 6x. So that part I get.
Okay. 10x cubed minus 6x? So when you differentiate 10x cubed, what you get?
I get 30x squared.
Good. And what
So
is the
it's
other part you
minus
get?
6x.
Minus 6x, so you don't differentiate the 6x.
No, I'm saying that it's 10x cubed minus 6x squared. You left off the squared.
Yeah, that was clear. Yeah.
They're supposed to,
Yeah,
oh,
2x
yes.
squared times
That is what
3.
messed me up. Okay.
Yeah.
Oh, that is what messed
You
me up.
must,
Okay, so
must get
that's
it
where you
now.
don't get the 12x. Okay, all
Yeah.
right.
Factorize,
Never
yeah.
mind. All right, I got it, sir. Thanks.
Good job. And you see, this is what happens. Students in the class are understanding and learning and can correct your errors. Very nice. I'm really, very proud. All right. If the things of the storytelling done, I shall be moving into the quotient aspect of it. Sir, you're moving too fast. All I'm doing is presenting the rules. I present the rules and I'm giving you an example of each so that I can cover all the rules and then we can look at the past questions. Rockstone, we have 5 minutes. Come. Other rule. The denominator, right for me, the denominator.
You're not seeing it, sir.
You know, see, no, me not show you, me say right. The denominator times the differential of the numerator. The denominator times the differential of the numerator minus the numerator times the differential of the denominator all over the denominator square.
Sir, go on again, sir, because you move too fast.
The denominator
Yes, sir.
times the differentiation of the numerator minus the numerator
yes, sir.
times the differentiation of the denominator all over the denominator square. So what you should have is the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. All over the denominator square. Are you okay?
Not
Yes,
quite.
sir.
So the last part is the differentiation of the denominator all over denominator squared.
Yes, sir.
Waiting
Let
on the
me see.
example, sir.
Waiting on the example. There goes the
Yes, sir.
example. X squared over x plus 2. X squared over X squared plus 2. Watch your screen. The denominator, don't you see the denominator is X plus 2?
Yes, sir.
Yes, sir.
Yeah, man, the denominator times the differentiation of the numerator. What is the numerator? X squared, don't?
Yes,
Yes,
sir.
sir.
And when I differentiate the X squared, what do I get? 2x. So do you see me have another story? You see when you're in big school, you see this dot means to multiply. So sometimes you see me put a dot between it, it don't means a decimal. When you're in big school, that dot now means multiplication.
I know that long time.
Okay, good
No,
job.
long time, sir.
Okay, so it's not a secret then. All right. So the denominator times the differentiation of the numerator, differentiating the numerator x squared, I'm going to get 2x, minus the numerator minus x squared, that's the numerator, times the differentiation of the denominator. When you differentiate the denominator, what do you get? When you differentiate x plus 2, what do you get?
Oh, 1, sir.
1. Yes, man. And that's why I have the 1 right there, so. And that's why I have the 1 right there, so. And that's why I have the 1 right there, so.
Just
And then it's going to be all over the denominator square. Give me a minute, please. You hear? Look at it. Oh, but then again, no, class. So, give me 2 seconds. Don't move. Don't move. All right, guys. Are you seeing what is happening there?
Yes, sir.
Okay, good job. All right. Look at that for me. Look at that for me, and then we will continue on Friday for the first part of it. You hear?
Okay, sir. Sir, how long is the test going to be on Friday?
You're saying something?
Yes, sir. I'm asking how long the test is going to be on Friday.
Maybe 5 hours. Listen, don't stop worrying yourself, man. Come off for the call and stop worrying yourself. Just prepare yourself and then a good man. Sure.
Sir, can we do the test before you teach?
Well, I think you can lose the information.
Yes, sir.
All right. So what needs to happen then is that all of you have to come in at 5 o'clock. All right. So all have to come in at 5 o'clock.
Or sir, we could switch around the times like you suggested the last time.
Oh yeah.
We'd have our self-paced, maybe 5
So you
to
have the
6.
self-paced first. Right. So you
Right.
can have the self pace first, and then we're coming at
6.
we're coming at 6.
Yes, to give everyone else time to get home in order to. That works for
Right.
everyone else?
Right. Boss, please.
Yes,
Right. So you can just do that for me, all right?
all right, sir.
Okay,
Yeah,
take
send the
care.
selfies. Bye, boy.
Hey, Sash.